So, what's responsible for the atomic bomb? Today I'll be talking about how a nuclear bomb works.
FBI, open up!
Okay, no, I won't be talking about how a nuclear bomb works, but I'll be talking about nuclear fission. Something that's good to us and bad. Mostly bad, probably. But nuclear fission is responsible for most of our electricity and bad nuclear disasters. But I haven't even talked about what nuclear fission is. Before we dive into nuclear fission, we need to learn some prerequisites. Number 1. If you remember from the last video and about the 4 fundamental forces, but there are 3 forces that we need to focus on: electromagnetism, strong nuclear force, and weak nuclear force. And if you don't want to come back to that video, then here are quick definitions. Electromagnetism has to do with electrical charges and magnetism and relationships between them, as well as waves and its radiation. But electromagnetism in nuclear fission will be mostly about magnetism. Strong nuclear force is about holding the atom's nucleus together, while weak nuclear force is responsible for nuclear decay. Number 2. Let's take a quick look at the periodic table of elements. Let's take iron, for example, and you'll see some goofy numbers. The 26 you see at the top is the atomic number, which determines the number of protons in that atom, while the number with a bunch of decimals is the atomic mass, which is the mass of both protons and neutrons combined. And let's say we want to make our element to look fancy. So we put this element symbol, in this case it's Fe. We put the atomic mass at the top and the atomic number at the bottom. The last detail we must go over is that neutrons have a mass of 1, or this number, an atomic number of 0, while protons have a mass of 1 and atomic number of 1. And we won't discuss electrons really. This type of notation is important, especially since we'll be doing some equations with it. Number 3. Another one is that the atomic mass can be higher with more neutrons than the original atomic mass, and this element would be called an isotope, and we will write it like this, or this. I don't really know. This chapter is really important as we go on, and well, see you on the next chapter. So, what is nuclear fission? Nuclear fission is a process by which very unstable atoms split due to an intake of a neutron into 2 other stable atoms with more other neutrons spreading, which releases a lot of energy because of Einstein's equation, E = mc squared. Matter is the densest form of energy, and with matter turning into energy, things won't go well. Also, elements with an atomic number of 90 or higher will most likely decay radioactively. Let's take a famous element that is used in nuclear fission: uranium-35. This atom is so humongous that it is hard for the strong nuclear force to hold it in with the electromagnetic force acting upon it, since protons have a positive charge and similar charges repel. The atom is having a problem. Let's say that a speedy neutron comes out of nowhere, don't ask me why, and let's add that a uranium-235 atom was in the vicinity. The neutron will suddenly collide and merge with the uranium-235, turning into uranium-236, but it won't be uranium-236 for too long, and so in a split second it will split into 2 other atoms, krypton-92 and barium-141, plus 3 other neutrons, and therefore releasing a big amount of energy. But this isn't limited to krypton and barium. As long as their atomic number is both equivalent to 92, as well as their atomic mass being equivalent to 235, plus the 3 other neutrons. This can also turn into a chain reaction by having millions of other uranium-235 atoms with neutrons smashing into other uranium-235 atoms will cause extremely colossal amounts of energy to the point till it's equivalent to a nuke. Nuclear fission is extremely dangerous, and not for its energy being released, it's the radiation. These gamma rays that came from the fission are so vigorously energetical that they will pass through your skin into the cell and knock out parts of your DNA. This is the cause of cancer, unfortunately. But not everything is supposed to be bad, nuclear fission has some uses. For example, we use it to produce mass amounts of electricity from nuclear reactors, which don't pollute anything but steam. But in conclusion of this part of this video, we've learned about nuclear fission and how the process works by using uranium-235 as an example, as well as the dangers and the good side of it. Next chapter will be about equations. Now, this will be a short chapter, and since you've learned a lot about nuclear fission, we'll write this out. And trust me, it'll be very, very, very easy. And I guarantee it won't be like this. But anyways, let's get to the process. First, we discussed that a neutron will be needed to start this process. So we put the notation of a neutron like this. And then we'll need the uranium-235 atom too. We'll also put a plus symbol in between. After that, we'll put an arrow to signal the ongoing transformation. Now, it's optional to put in uranium-236, but let's say we don't. So, instead, we put in barium-141 and krypton-92, and the 3 other neutrons written this way too. You can also do this with other elements, so yeah. Let's go! Congratulations. Now you know everything about nuclear fission. Flex to your friends that you're now big brain, and I'll dip out.
One says, now I am become death, the destroyer of worlds. I suppose we all thought that.